Chapter 7 Alternating Current. Yes. Questions from additional exercise. Exercise 7.13. A coil having inductance 0.5 Henry and resistance 100 ohm, supply 240 volt 50 hertz. Your question is, what is amplitude of current and time lag between Vm and Im? See, here you are given inductance, means L is equal to 0.5 Henry, resistance R is equal to it is 100 ohm. A coil having inductance and resistance both, it behaves as LR series circuit. LR series circuit. Okay, so yes, you have inductor LR. Then 240 volt means it is VRMS. VRMS it is 240 volt, and frequency F is equal to it is 50 hertz. Frequency F is equal to it is 50 hertz. So yes, first of all you have to find what is omega. Omega means it is 2 pi F. Then to find inductive reactance, that is XL is equal to it is omega L. Okay? Yes, because you are given inductor, so that's why you have to find its inductive reactance, that is XL is equal to omega L. Now, as you have to find what, yes, Im. What is equation of Im? Equation of Im is equal to is Vm upon Z. So what is impedance of circuit? Impedance of circuit. Impedance of circuit. Z is equal to, it is under root R square plus XL square. Yes, you are given value of R. Here it is an XL you will find, so you can easily find what is its impedance. Then how to find maximum current? To find maximum current, first of all you have to find maximum voltage. So what is V maximum? V maximum is equal to, it is root 2 VRMS. It is root 2 VRMS. Okay. Then how to find Im? So yes, what is equation of Im? Im is equal to, it is Vm upon Z. Simple. Im is equal to, it is Vm upon Z. So first of all, with the help of frequency, find omega, then find XL, then find impedance of circuit, then find Vm, and then find Im. So yes, you will get your first answer. Now, yes, what is time lag between Vm and Im? How to find time lag? How to find time lag? See, here, to find second question, yes, we know equation, that is tan delta is equal to, it is omega L, sorry, it is XL upon R. It is XL upon R. Yes, in only LR circuit, tan delta is equal to, it is XL upon R. You have value of XL, you have value of resistance. So yes, you have to find value of delta, and you will get this value of delta in degree. You will get this value of delta in degree. Yes, you have to find. Okay, yes, you have to find. Okay. Now, how to find this time lag? Yes, I can write this delta is equal to omega t. I can write this delta is equal to, it is omega t. Yes, I can find this delta is equal to, it is omega t. So therefore, okay, I can replace this del by omega t is equal to whatever answer you got in degree. Now, as this answer is in degree, you have to convert it radian. So therefore, omega t is equal to blank degree into, it is pi by 180 radian. It is pi by 180 radian. Clear about this? Okay, and then yes, make t a subject. When t is equal to, it is blank divided by omega t into pi by 180 second. Into pi by 180 second. You will get your answer. You will get your answer. Clear? So yes, it is, I think, simple question which is based on calculations only. Omega, XL, impedance, Vm, Im, then find del, and yes, you have to put this value of del. It is in degree. Pi by 180, you have to convert it in radian and make t as subject. Clear about this? Okay. Now, another question after it. Exercise 7.14. Exercise 7.14. See, what is question? Yes. If supply in exercise 7.13 is 240 volt at 10 kilohertz, means what is change? Here supply is 240 volt 50 hertz. Here supply is 240 volt and 10 kilohertz and 10 kilohertz. So there is only change in frequency. There is only change in frequency. In this case, frequency is 10 into 10 raised to 3 hertz. Or you can write it as 10, 1, 2, 3 hertz. Okay. So yes, you have to find what changes. So simple again. With the same value of L, with the same value of R, VRMS is also same, only frequency is changed, that is 10,000. Omega changes, XL changes, impedance changes, VM will be same. IM changes, del changes, this time will change. Just this time will change. And yes, what is current in this case and what is current in this case, that you have to compare. That you have to compare. And yes, that comparison you have to write. That comparison you have to write. Clear about this? So yes, these two questions. And yes, in textbook you are given one statement. Okay, when it is at higher frequency, then what happens? That statement you have to write. Okay? So yes, it is 7.13 and 7.14, they are linked with each other. And similar questions. See, 7.15. Next question is, it is 7.15. See what is question? Here it is. 10 microfarad capacitor and 40 ohm resistor. They are connected in series with supply 110 volt and 60 hertz frequency. What is IM and what is time lag between VM and IM? Another question. C is equal to 100 microfarad. R is equal to 40 ohm. VRMS is equal to, it is 110 volt. Frequency F is equal to, it is 60 hertz. Okay, so yes, it is, they are connected in series. So here it is LR series circuit, here it is RC series circuit. Here it is RC series circuit. Okay, again, first of all, you have to find omega, that is 2 pi f. Then you have to find XC, means it is 1 upon omega c. Yes or no? Yes or no? Yes, it is. Omega is equal to 2 pi f, then XC. Then you have to find impedance of circuit. Impedance of circuit. And that impedance of circuit, Z is equal to, it is under root R square plus X square. It is under root R square plus X square. Then, yes, Vm, you have to find Vm. So Vm is equal to, it is root 2 VRMS. Yes or no? Yes, it is. Then you have to find Im, that is Im is equal to, it is Vm upon Z. Value of Z you will get from this equation. Okay? Then yes, you will get value of M. Then, yes, then you have to find tan del. Tan del is equal to, it is Xc upon R. Tan del is equal to Xc upon R. And again, you will get value of del in degrees. You will get value of del in degree. Then you have to replace this del by omega t, and you have to convert this degree in pi by 180 radian. In pi by 180 radian. Then, yes, then t is equal to, it is blank divided by omega into pi by 180. Sorry, you will get your answer in second, and t in second. Clear? So yes, it is another question which is based on again equations. What is difference between these two questions? It is LR circuit and it is RC circuit. Clear? Now again, 7.15, see 7.16. If supply in 7.15 is 110 volt and 12 kilohertz, yes, here what is supply? 110 volt, 60 hertz. Here what is supply? 110 volt and 12 kilohertz. 110 volt and 12 kilohertz means frequency is changed. Okay, higher frequency. Yes, in both cases you have they have considered higher frequencies. So what happens at higher frequencies? Again, also, again here value of frequency 12 into 10 raised to 3 hertz. So is equal to, it is 12, 1, 2, 3, and here it is hertz. So yes, value of frequency changes. Again, F, C here, C same, R same, VRMS same, F is change, omega change, XC change, impedance change, VM will be same, IM change, del change, so it will be change. And again, yes, you have to compare current. Okay, what is current in this question and what is current in this question, and you have to write statement. Simple. So yes, there are 4 questions that you have to solve. Okay, there are 4 questions that you have to solve. See, students, in physics, calculation is important. Okay, if you can calculate such questions easily, okay, by yourself, then it will be easy for you in exam. Okay, I can solve these all questions. I will write direct values. But if you calculate step by step, so you will understand how to calculate, how to use calculator. Okay, so that's why I am giving these all questions in homework to you. Clear? So yes, don't keep it blank like this. Okay, you have to calculate. Okay, next question. Next question, exercise 7.18. See, 80 millihenry inductor, 60 microfarad capacitor, they are connected in series with supply 230 volt 50 hertz and having negligible resistance. Okay, yes, you have to find A, B, C, D and E. Such questions. IM, IRMS. RMS values of potential across each element. Average power transfer to inductor, average power transfer to capacitor, and average power of circuit over a cycle. Yes, you have to find these 5 questions. See, question is simple. Inductor and capacitor, they are connected in circuit, means it is LC series circuit. Okay, chalo. L is equal to 80 millihenry. C is equal to 60 microfarad. Yes, hello, you have to convert. Okay, it is 80 into 10 raised to minus 3 Henry. It is 60 into 10 raised to minus 6 Farad. Okay, yes, what is AC supply? VRMS is equal to 230 volt and the frequency F is equal to 50 hertz. So yes, from frequency, first of all you have to find omega, that is 2 by F. Then find capacitive reactance and inductive reactance. That inductive reactance XL is equal to omega L. Yes, you know its equation. Then capacitive reactance XC is equal to, it is 1 upon omega RC. It is 1 upon omega C. So yes, first of all you have to find each and everything step by step. So if it is right, you will get your marks. Okay, so yes, omega, XL, XC. Now LC series circuit. So for this LC series circuit, first of all you have to find what is impedance. So yes, impedance of circuit. Z is equal to impedance of circuit. Z is equal to, yes, see here you have to XL and XC. If you know equations for LCR series AC circuit, Z, it is under root R square plus under root R square plus XL minus XC whole square. R is equal to 0, so impedance Z is equal to, it is XL minus XC or XC minus XL. Z is equal to XL minus XC. If XL is greater than XC or Z is equal to, it is XC minus XL. If XL is less than XC. Okay, here yes, you have to use this equation because in this question XC is greater than XL. So yes, what is equation of Z? Here is equation of Z. Okay, then yes, you have to find what is IRMS. IRMS is equal to, it is VRMS upon Z. Here it is VRMS, Z you will find from this equation. Simple. How to find IM? IM is equal to, it is root 2 IRMS. So simple. First 2 questions, both simple. Okay, then it is 8. Question B. RMS values of potential across each element means VL across inductor. VL is equal to it is I RMS XL. VC is equal to it is I RMS XC. Simple. VL is equal to I RMS XL. VC is equal to I RMS XC. That is potential across each element. Then question C. What is average power transfer to inductor? We know that for inductor phase difference between V and I is pi by 2. So therefore average power is equal to 0. Simple. Question D. Yes, you have to write only one statement. Okay. What is average power transfer to capacitor? Again, for capacitor phase difference between V and I is pi by 2. So therefore again phase difference is 0. Simple? Yes. What is question E? What is total? Oh hello. Total means it is LC circuit. So if average power transfer to capacitor 0, average power to inductor is 0, then what is total power? It is also 0. Okay. The total power that is P is equal to PL plus PC is equal to ADC. Simple. So you see this question is very easy. You have to find your A, B, C, D, E. These 5 questions will see. It is easy. Clear about this question? So yes, exercise 7.18, it is easy. Now exercise 7.19. Okay, exercise 7.19, see. In exercise 7.18, if resistance 15 ohm is connected in series, then what is average power over each element? Total power absorbed. You have to find this. So see, in exercise 7.8, in this question, there are only 2 components, inductor and capacitor, but if resistance is connected, that is R is equal to 15 ohm, then it becomes LCR series AC circuit. It becomes LCR series AC circuit. Okay, and yes, for LCR series AC circuit, what will change? Impedance of circuit. What is impedance of circuit? Impedance of circuit Z is equal to, it is under root R square plus XL minus XC whole square. Okay, yes, you already know what is value of XL and XC, so you have to put directly value, okay, and R is given. So yes, from this value you can find its value Z. Now IRMS is equal to, it is VRMS upon Z. VRMS again from this question, that is 230 volt. Okay, so yes, you can easily find what is value of IRMS. Now power over each element. So what is power over resistor? What is power over resistor? Yes, it is VRMS IRMS. Simple. It is VRMS IRMS, or you can also say it is I square RMS. It is I square, or just you can use directly this equation. Okay, that is VRMS IRMS. Simple. Simple. Yes or no? Yes, it is. Yes, it is. Okay, so PR is equal to, it is VRMS IRMS. Then what is PL? 0. What is PC? 0. And therefore what is total power? So total power P is equal to, it is PR plus PL plus here it is PC. Simple. So yes, when resistor is connected, power is distributed only in resistance. Power is distributed only in resistance. Clear about this? Yes. Here PR is equal to this VRMS IRMS. Here it is cos delta. Here it is cos delta. Clear? Yes or no? Yes. PR is equal to VRMS IRMS cos delta. And what is value of cos delta? Yes. Cos delta is equal to, it is R by Z. Cos delta is equal to, it is R upon Z. So yes, from these values you have to find. Yes, you have to find what is power or resistor, inductor, capacitor, and then total power. So yes, there's only 6 questions. Only 6 questions. You have to calculate. You have to calculate. Clear? So yes, this is it for today from my side.